Hi all, this is Alan with Bothell STEM Coach, and today we are continuing on with AP Physics 1, looking at circuits problems. As usual, I suggest you pause the video, try to do the problem on your own, and then come back after you've attempted it. So light bulbs of fixed resistance, 3 ohms, 6 ohms, and a 9-volt battery and a switch S are connected shown in the diagram above. The switch S is closed. Calculate the current in bulb A. Okay. So the current goes through here and then splits through 2 resistors, but I could simplify this circuit into just the 9 volt and then 1 resistor. And the way I would do that is I would collapse these resistors. These two are parallel resistors, and they're parallel because both sides of the resistors are connected to the same node. Like these two are connected and these two are connected. So both terminals or both ports or terminals or nodes on the resistances are the same. So parallel resistance is 1 over R is equal to 1 over 6 plus 1 over 3. So R is equal to 1 over that. So that would be the resistance, just collapsing the those two in parallel. I think it's 2, but let me just double check with my calculator. Yeah, that's 2 ohms. And then now that I've collapsed it to this, the 2 ohms, these to make 1 resistor. The 2 ohms is in series with this, so this is 5 ohms right here. Okay, and then the current through this, I can use Ohm's law because it's 9 volts across this terminal, the resistor. So I would say V is equal to IR. So I is equal to V over R, and that's 9 volts over 5 ohms. 9 divided by 5 is 1.8 amps. Okay, that's the first one. Which light bulb is the brightest, and justify your answer. Okay, to know the brightest, I need to know which one is going to dissipate the most power. So, let's see. So, I need to calculate the power for each resistor. For bulb A, because I know the current through this resistor, I'm going to say that the power is, I'm going to use this equation, I squared R. Because I know the current, I know the resistance, and I know the current going through the resistor. So 1.8 amps squared times R. And this R is 3. So 1.8 squared times 3 is 9.72 watts. Whichever one has the most power, by the way, is the brightest. Okay, so for bulb B, the problem with B and C is this current splits between these two paths. So it's not 1.8 amps through these. It's the total of these is 1.8 amps, but I need to know specifically the current through each of the bulbs in order to calculate their power. So I don't necessarily want to use current. So for B, for example, I could say one way you could do is I could find the voltage. Okay, that could be helpful. Well, to find this voltage here, I need to know what the voltage drop here was. And the voltage drop across this, I can calculate as the voltage was I times R. And that's 1.8 amps times 3. And that's 5.4 volts. So what that tells me is the voltage drop from here to here is 5.4 volts. If the total drop from here to here has to be 9 volts, this drop has to be 3.6 volts across these two resistors. Okay, because basically 9 minus 3.6 has to be the 5.4, and the 3.6 is across here. Basically, it's like this voltage drop plus this voltage drop have to equal 9. And if it dropped 5.4 volts here, it has to drop 3.6 volts here. Okay, so for B, now I know the voltage across it. I can use power is equal to V squared over R. And that's equal to 3.6 volts squared divided by 6 ohm. 2.16 watts. And then for C, I also know the voltage. It has the same voltage as B. So that's 3.6 volts squared over 3 ohm. And that would be 4.32 watts. Okay, so I calculated the wattage of each of these. A has the largest. So A. Switch S is then opened. By checking the appropriate spaces below, indicate whether the brightness of each light bulb increases, decreases, or remains the same. So now I cut this off, right? So my circuit is just these two in series now. Well, bulb C turns off. It has no more current flowing through it, so no more power going through it. So bulb C decreases for sure. Now what happens to A and B? Well, so for A, so you see the total current flowing now, because the circuit is different now. It's just these two in series. So when I do my equivalent circuit, for example, it's just these two in series. This is 9 ohm instead. So that means 1 amp flows, because V equals IR. 9 volt equals I times 9 ohm. So I is equal to 9 volt over 9 ohm. That's equal to 1 amp, right? So now it's 1 amp. So bulb A has gone down, because before it was going through 1.5 amps or 1.8 amps. Now it's only 1 amp. So this power decreases also. This bulb. Bulb B, its current, let's calculate its current. Because I know its current is also 1 amp, because now the 1 amp flows this way and it flows this way, because it can't split up. The 1 amp has to go through here. It's I squared R, and I can use 1 amp squared times the 6 ohm resistor. That's equal to 6 watts. So B gets brighter. Okay, because before it was 2.16 watts, now it's 6 watts. So I hope you found that helpful. I'll see you in the next video. Thanks for watching the video, guys. Please leave a comment, like, or subscribe below to catch up more of the content. And see any links below. I offer free homework help on Twitch and Discord. See you guys in the next video.